Welcome to this video on horizontal projection. Now in this video you'll need to be able to use the constant acceleration formulae as you can see here. Now with these, the first two that I've written, these are the ones that you'll probably use the most, but you may use any of these when solving a problem, but like I said, these will be the ones used the most. Now these will be for all of our vertical motion. Okay, now the vertical motion is purely because this will be under a constant acceleration, which will be acceleration due to gravity. Okay, so you would use these formulae to help you for any kind of parts when you're looking at just the vertical motion. Now the horizontal motion is a little bit different. Just write this down. And the reason that is that there will be no acceleration. Effectively, in this case, acceleration would equal 0. Because what's happening is it's going to be at a constant velocity. Okay, so for that, you're basically using S equals VT. It's essentially just distance equals speed times time. There's no difference there. I often use S equals UT. You might see me write that down a bit. Obviously it's the same thing. I will sometimes write U just because I'm sticking with the same parts of the question, with U being that initial velocity, but it makes no real difference. So vertical motion acceleration is due to gravity, or remember in maths we tend to use 9.8. I know those who do physics will use 9.81 in general, but in maths we use 9.8. So acceleration due to gravity for vertical motion, acceleration is 0 for horizontal motion, so it's just effectively speed equals distance times time. And that is because if I take two objects, I drop one and I throw one horizontally, then they should land or hit the floor at the same point. Not the same point, at the same time. Obviously the one I threw horizontally will be further away, but the actual time it takes to drop from that height to the floor will be the same. Okay, now obviously in real life there are things like air resistance and stuff that does alter these slightly, but in general that is how it works, and that is how we're able to think about these when we're solving these problems, in splitting up into their horizontal and vertical components. Now today we're just going to be looking at a horizontal projection, so when that initial velocity is horizontal. The next video is then we'll look at it when it's going at an angle, so we'll build up as we go through these. And I think, like always, easiest place to start is with an example. So here we have a particle projected horizontally at 20 meters per second and a height 40 meters above the horizontal surface. So we need to first find the time taken for the particle to hit the ground and the total horizontal distance travelled in that time. Now, when I do any mechanics question, what I'll always do is a little sketch. I think it's important. Some problems, this problem's not too difficult, but I do think it's important to think about what's happening in the sketch. It can help you work out exactly what you need to do. It can also mean that you might spot something when you're solving a problem that you didn't spot initially, just from reading it. But as you set out your sketch, usually things become a little bit more obvious that perhaps, again, like I said, you might not have noticed the first time around. But these ones, they are quite straightforward, but I'll still just pop my sketch in anyway. So here we have our rough little sketch. It's a particle projected horizontally, but obviously as it goes, it's going to slowly creep down towards the ground. I know that, acceleration is going to be due to gravity in this direction, so heading down. Now, when I'm looking at the first one, I'm just looking at the time it takes for the particle to hit the ground. So this I need to resolve vertically. And when I'm resolving vertically, you want to essentially pick a direction as positive. So you could pick up, you could pick down. I think in general it makes more sense to pick the direction that's, that you're actually going in this case. So obviously this, as it moves along, it is going to drop down. So I'm going to pick down as the positive direction. So you'll see this when I do it. So I'm going to resolve vertically, and I'm going to put that as a down arrow to show the positive direction is down. You could equally, say, for example, you're taking this as the positive direction, or you could write it in words, say, downwards, positive, something like that. Just need to show which direction you're taking as positive. Now, this is only vertically. So if I look at the initial velocity of 20 meters per second is horizontal. Initial velocity in this vertical axis is going to be 0. Remember that components, things that are perpendicular to each other, 90 degrees, they don't affect each other. So that horizontal velocity does not affect this vertical one. So u is just 0 meters per second. Just get rid of that, so just see the 0. Now I know that A is going to be gravity, and it's acting down. Down's the direction we picked as positive, so this is positive. Now, what else do we know? Right, we know that the vertical height, so I'm going to call this an SY. Actually, I'll add the U in as a UY as well, just so that you know that it's the distance or the displacement in the vertical direction. And that one's going to be 40, and we need to find the time. So we're looking for a formula with U, A, S and T. And as you should have guessed, it's S equals UT plus a half AT squared. Substituting obviously what you know. U being 0 makes this a lot easier for us to do. And it's just now a simple bit of rearranging. If I multiply by 2, I get 80. Divide by gravity, that is with my t squared. And all I need to do now is take the square root, and I want the positive value. Now, that obviously gives me plus or minus 20 over 7. As I said, we need the positive one. You shouldn't really need to put the plus or minus in, but sometimes I do like to make it known that, I know it's plus or minus when I square root, and then it is the positive answer that I want. Okay, you don't, you can just jump to this one. It should be fine. I just personally like to give no one an opportunity to even contemplate dropping a mark for me. So that's my first one, part A done, nice and easy. Now part B is that total horizontal distance. So what we want to think about for part B, now what I will actually do is let's change the colour up, make it a little bit easier for you guys to follow. So we're looking at that distance there. Now if you remember, for the horizontal one, I said we need basically distance equals speed times time, or speed equals distance divided by time, however you want to rearrange that, or S equals VT, or S equals UT. It doesn't really matter. So we want this horizontal distance. We know that velocity is 20, and now we know the time, and the time is this 20 over 7. So that will give me 400 over 7, or as a decimal, that will be 57.1 meters. Obviously this is the 3 significant figures. If you just check the front of your exam when you do it, you will see that it does say, if you're going to round things, 3 significant figures is that kind of standard that that they expect. So, you know, here you are. Personally, obviously, I'd leave it generally in terms of a fraction unless told otherwise. But yeah, totally up to you. First problem, not too difficult with any luck. Let's look at another one, just slightly varies a little bit, but essentially it's along the same lines, just looking at the horizontal and the vertical components differently. Now, in this problem, you can see again now particle projected from point A, which is 14 meters above the horizontal, hits the ground at point B, which is 50 meters from A. Calculate the speed of projection of the particle. So let's start with a little diagram. So I've got my horizontal ground there. I've got a little bit for my direction that we're going in terms of the velocity, horizontal velocity, and then just some sort of curve that moves down and hits here. So we've got A, we've got B. Now we know this height from the horizontal is 14 meters. We also know that it's 50 meters, or B is 50 meters from A. It's not very clear now what this should be. Is it should have perhaps been a little bit more clear in terms of how it's written. If it wanted the horizontal distance, it will say the horizontal distance. Usually with this one, it will make it a little bit more obvious, just giving you, I would say, perhaps slightly more words, just that it is directly or exactly, or, you know, 50 meters, but just something so you know it's not the horizontal. Obviously this would be the horizontal distance, so quite easy to mistake, you know, which distances are needed. But the horizontal, it should be very specific if that's what they are looking for. And we need to find this U meters per second. Now, we essentially need to do a lot of what we did in the previous one. And the first step, resolve vertically. Just like in the previous one, this will enable us to find our time. So we know U is 0, we know A is gravity, I'm taking down as positive. S, Y is going to be 40. What else have we got? Oh yeah, time, what we're trying to find. So S equals UT plus a half AT squared. And then we've got 0 plus a half GT squared, and that is equal to, sorry, not 40, 14. What's going on with my eyesight there? So multiply by 28 over G equals T squared. So T, and that gives us, well, from the calculator, 2 root 35 over 7. Let's get it as a decimal, 1.69 seconds there, to 3 significant figures. Obviously, store that in your calculator. I often like to put a little letter next to my work as I've stored this in my calculator as A. If you're not sure how to store things, there is I do have a video, a short, just on bits in the calculator, so just check it out. This time I'm not going to bother writing plus or minus first, we just jump straight into the positive. Now that I've done that, I need to look at that horizontally, so let's resolve horizontally, and there we're using S equals VT. Now we have V, no, V is what we want to find, don't know what I'm talking about here. V is what we want to find, T is this 1.69, obviously I'll use the full value, and SX, that I actually need to find, don't I? But if I look at the question, obviously I've got 14 here, 50 here, and this is clearly going to be a Pythagoras, isn't it? Right angle triangle. So this is going to be 50 squared minus 14 squared and then square rooted. And that actually gives me a nice whole value of 48. So there we have it, 48v times our 1.69. So v is 48 divided by the answer is stored in A, and we get 28.4 meters per second. So there you have it, nice and easy, same kind of process as the first question, just finding that initial speed or that initial velocity there. And yeah, nothing too much with this one. So I've just done 3 questions for you to have a go at. As always, the answers will be towards the end of the video, and call back and look at the next one where we look at particles being projected at an angle. If you have enjoyed this video, before you carry on, if you have enjoyed it, please consider hitting that subscribe button and give me a thumbs up or a comment down below.